Happy day to you all. This is Orekoya Fumi Olusegun, Mathematics Physics Fundamentals on YouTube. Mathematics Fundamentals on YouTube. Today we are going to take a topic under physics, and the topic is exercise on electric field intensity. Now, the question is, what is electric field intensity? Let me say I have electric charge. This electric charge now, call it electric charge Q. Electric charge capital Q. Let's say this is electric charge. If this charge is positive, the charge will have electric line of force where the electric force will be acting, coming out in all direction outward from the positive electric charge to come out. So in such a way that if I put any other charge in this field, the charge can be positive or negative. This charge is called a test charge. If I put a test charge here, this test charge will experience the electric field around this electric charge. What do we mean by electric field? Electric field is the total region where the electric force can be experienced by another electric charge placed within that region. So if this charge, let me call this one a source charge. Source, that means the source charge is the one providing the electric line of force, and this one is a small charge. Let's call it a test charge. This test charge is to see the effect of this line of force as the test charge is moved close to it. Now the electric field around this test charge is assumed to be negligible compared to electric field around the source charge, because if you are using the same electric charge, the effect of one field will not be as noticeable on the other one if these two charges are of the same magnitude. That's why we are using a smaller test charge. So this test charge will experience a force. If this test charge is positive, from the fundamental law of electrostatics, like charges, like for instance plus, they will repel. That means this test charge will move away with a force F. This particular force F is called the electric force. F is called electric force. So it is this force that will drag this charge away from this source charge. Now the electric field intensity E is the effect of this electric force per unit test charge. So I can have it as this electric force per unit test charge. Now if we and then you know that the unit of force is in Newton, and the unit of electric charge is in Coulomb. So the unit of electric field intensity is Newton per Coulomb. Now the electric force can be cross multiplied. This equation can be cross multiplied so that the electric force become Q times E, QE. This is equation 1 that should be noted. Now this electric force also has a formula according to Coulomb's law. Let's consider these two charges now separated by a distance r. This charge is at point P1 and this other charge is at point P2. The distance between point P1 and point P2, let's take it to be r. Now when these charges are close to each other, they will impart electric force on one another. The electric force between these charges may be repulsion force if the two charges carry the same charges, like when the first one carry positive, the second one carry positive, or when the first one carry negative, the other one carry negative charge. There will be repulsion between these electric charges. That will be force of repulsion. Otherwise, if the first one carry positive charge and the second one carry negative charge, the two charges, they will attract each other. So electric force is simply force of attraction or repulsion, unlike gravitational force, which is always attraction only. That's different between one difference between gravitational force gravitational force deal with masses. So masses experience force of attraction between them, whereas electric charges, they experience either force of attraction or repulsion depending on the type of charges the two electric charges are carrying, the sign. Now, according to Coulomb's inverse square law, Coulomb inverse square law says that the force between these two charges is directly proportional to the product of the two charges and inversely proportional to the square of their separating distance. That's why it is called inverse of the square. So if we remove this proportionality sign F, I can have the constant K of proportionality. So we have K Q divided by R square. This one expression that I have here now is another formula for electric force. So I'm having two formula now for electric force. The first formula, like we derived the other time, electric force is electric charge times electric field intensity. The E is called electric field intensity. Please take note. E is electric field intensity. Electric field intensity. So because these two forces, they are the same electric forces, we can equate this expression to each other. The first one is Q times E, that is QE. I can equate it to the second one, that is Q divided by R square. The Q, the electric charge on both sides, cancel out here, so leaving electric field intensity E to be K then times this source charge divided by R square. Now let's look at equation here. The question says something that find the magnitude and direction of electric field E 1 centimeter below 35 micro coulomb charge. Now this one is talking about, because this parameter we are given is a positive number, that means the charge we are going to deal with is a positive charge. That's charge. So this charge produces electric force in all directions. This one is to the north, this one is to the south, this one is to the east, this one is to the west, and this place is between north and east. So this is northeast electric force. This one is between south and east, so this one can be called southeast electric force, line of force. Then this place is between north and west, so we can call it northwest electric force. Now the question says that we should find the electric field intensity 1 centimeter below 35 coulomb charge. So this particular charge now, we want to find the electric field intensity E that is acting at this particular point downward, that is toward the south. So the direction of that electric field intensity is to the south. Now like I said the other time, the electric field intensity E is given as KQ divided by R square. Now before we move further, I want us to have the idea also of okay, I've already given us the units of electric field intensity. Okay, let's continue. Now this K of proportionality is given as 9 times 10 raised to power 9. Now let me derive the unit for this K. We know that electric force is given as KQQ divided by R square. So let me dissolve the formula. So I have FR square divided by QQ is equal to K, and the unit of force is Newton. The unit of distance R is in meter, so the R is square, so meter square. And the unit of this coulomb is coulomb. The unit of the charges are coulomb square. So that means the unit of this K is what I have here. So I can write it in front as a N meter square divided by c squared. That's the units of this constant k. And this constant k also have an expression. The constant k is also given as 1 over 4 pi E naught. The E naught is called permittivity of free space. So now let's go to the exercise given to us. In the exercise, this is my q. The q value given in the exercise is 35 microcoulomb. Micro simply means times 10 raised per minus 6, that is coulomb. Now, the distance from this charge is given as, distance r is given as 1 centimeter. From the word century, century means 100. So centi means fraction. So centi means 1 over 100. So this one can be written as 1 over 100 meter, which can be written as from law of indices as 10 raised per minus 2 meter. That's distance r. Now, slotting all these value in and the value for constant k, which is this, slotting them inside this equation. In a nutshell, this equation, I want to bring it out somewhere here. I want to rewrite it out. So my E now is equal to k q divided by r squared, which is equal to, so E now is equal to 9 times 10 raised per 9 times the q is what we have here, 35 times 10 raised per minus 6 coulomb. That's 35 times 10 raised per minus 6. Then divided by the r square is what I just got here, 10 raised per minus 2, then everything squared. Now, I can simplify this now. 9 times 35 is 305. 315. From law of indices, 10 raised per 9, that's plus 9, times 10 raised per minus 6. So plus 9 minus 6, that's plus 3. So that's going to give us 10 raised per plus 3. Divided by, from law of indices, when we have bracket, we multiply the power. Minus 2 times 2 will give us minus 4. So this gives us 10 raised per minus 4. From law of indices, when you are taking a negative power upward, it becomes positive. So that means we are going to add 3 to 4. 3 plus 4 gives us 7. So I'm having my E to be 315 times 10 raised per 7. When we have whole number, the decimal point is outside this whole number. So I can count this decimal, I can shift it inside. 1, 2. I shifted it twice there. So I have 3.15. The number of shifting is 2. So you add that 2 to this power. So we are having 7 plus 2. That's 10 raised per 9 Newton per coulomb. So this is the answer to the question that is asking us to find the electric field. And the direction of that field is toward the south, because it is, according to the question, the intensity we are looking for is downward. I believe that we've learned something reasonable. Please, kindly remember to share, like, comment my video. You can copy the link of my video on your other platform and contact. And if you need a tutor on advanced mathematics and physics, do well to contact me through this email address, shegorekoya@yahoo.com. No, or shegorekoya@gmail.com. Sheg in a lowercase letter, Sheg Orekoya at Gmail. Please let every thing be in lowercase letter, please. gmail.com. Thank you so much. I really appreciate your patience. Have a nice day.